All right, so we had distance on question 1, and we've got displacement here on question 2. And displacement, we're only worried about how far away the person ended up. We don't care about the path taken, so we want to work and find out, how far away did they go. And so we have to do that when we have measurements that are not either parallel or anti-parallel, basically not lined up with each other. We have to do that with components. So think about it this way: person started here, went over a little bit, then walked up this way, and then came over again, and then walked up this way. And the displacement we're looking for is from the beginning to the end. We don't care about the things in the middle. Just they got there somehow. And what we need to do, because there's not an easy way to get this directly, is we split it down. We look at some of this as a horizontal displacement and some of this as a vertical displacement. Those are called components. We put those components together, and that's how we get an answer. So we have a displacement in the x direction, and we have a displacement in the y direction. So the displacement in the x direction is anything left and right or east and west. Typically, we'd say east is positive, but because we're not mixing and matching with these, we can just take the numerical value. So just 60 meters. And then east again, so that's another, looks like 37. And so the total displacement, if they go on straight over here on the bottom, is 97 meters. Then we need to see how far they go up, how far they head to the north. Again, technically, we'd be looking at positive and negative integers, but notice that it's north and then north again. So these are just going to go together. The first movement here is 21. The other one is 24. And so if we put those together, we have that this component then, oops, I was thinking ahead to the answer, got carried away. So this is 24, and then the answer is 45. All right, but remember, those are the pieces, the components that help to make up this solution. And so we have to bring forward something I know you've seen before. It might have been a little while, but if you look carefully, you can tell that this is a triangle, and more importantly, a right triangle. And so in the end, we can do Pythagorean theorem because, after all, we are looking for one more side in our right triangle, and this is our general way of handling that. The good news is that everything's in meters, so I expect an answer in meters, and the question is, indicating meters. So I really just need to evaluate. So I'm not worried about plugging in the meters and the units. I just want to plug in the numbers and see what that turns into. So 97, 45, and then I don't know what the C is on the end. So if I start running this through a calculator, I get 9409 for this part, and it looks like 2025 for that part, and I still don't know what C is, so I still don't know what C squared is, other than it's related to these numbers. So adding that together, 11,434, this part is still C squared. And then I don't want the square of the hypotenuse, I want just the hypotenuse, just this displacement here. And so in order to get rid of that, I've got to take a square root. And so C is the square root of 11,434, which is technically the exact answer, but that ends up being approximately, looks like 106.93 meters.